In section 2, there are 3 theorems that we are going to have to be able to prove on our test over chapter 6. So today we're going to take you through those. And if you've got your chapter 6 packet of papers, we want you to flip to the page that looks like this one. And here are your 3 theorems we're going to prove. The first one, the given here is that our opposite sides are parallel to each other. So that makes it a parallelogram. And we're going to prove that these opposite sides are also congruent. So this is the theorem that says if it's a parallelogram, opposite sides are congruent. We're going to prove that right here. So first step, like always, is the given. Rather than rewriting all that, I'm just going to bring it over here. And that is given to us. Then if we go to step 2, if you go back to your given, we have parallel lines. Let's start with RS and UT being parallel. Here's RS on top. It's going to be parallel to UT on the bottom. And anytime you have parallel lines, we want to look for alternate interior angles. Since these lines are parallel, that's going to make angles 1 and 4 congruent to each other. But then we have another set of parallel lines. So we have to get that into our proof also. RU and ST are also parallel. That's these two. And same thing, when you have parallel lines, we're going to look for alternate interior angles. Angle 2 and angle 3 are going to be alternate interior angles there, so they will be congruent. And your reason, it's already put in there for you, alternate interior angles theorem. Since the lines are parallel, your alternate interior angles are congruent. Step 3, they put in for us also, RT is congruent to TR. Here's RT. It's shared by both triangles, so it's congruent to itself. That's going to be the reflexive property. And then if you look at what happens here, now in your 2 triangles, we have 3 sets of corresponding parts that are congruent. We have a set of angles here with 2 marks. We have a set of angles here with 1 mark, and then they share this side right here. It's congruent to itself. So the 2 triangles are set up for angle side angle, which is what we have here in step 4. So step 4's statement is just to tell which triangles are congruent. You can name them 3 different ways. I'm going to call this triangle on the left UTR. So that's going from the unmarked angle to the angle marked with 1 to the angle marked with 2. So if I go in the same order over here, that's going to be SRT. And those are congruent by angle, side, angle. And then just like we did back whichever chapter we did the congruent triangles, once the triangles are congruent, then the corresponding parts will be congruent. That's going to make RS and TU congruent. It's going to make RU and TS congruent. Last step is CP, CTC. Once the triangles are congruent, then their corresponding parts are congruent. There's our first proof. That's the proof of if the figure is a parallelogram, then the opposite sides are congruent. Let's go to the second one. Second one, again, we're going to start off with parallel lines. Opposite sides are parallel. That makes it a parallelogram. And this time we're going to prove that angle R is congruent to angle T. R and T are opposite angles. So this is the theorem that says if the figure is a parallelogram, then the opposite angles are congruent. We're going to prove that right here. So first step again is the given. In step 2 they put in for us, R and S are supplementary and S and T are supplementary. If you go back to your given, I'm going to put the picture in here, RS and UT are parallel. And same thing with RU and ST. And you'll remember we'll have a theorem back in section 2. We learned a theorem that said if the figure is a parallelogram, then its consecutive interior angles will be congruent. Well, that's what's happening here. R and S are consecutive interior angles. They're on 2 parallel lines, so they're going to be supplementary. Same thing with S and T. Those 2 are on these 2 parallel lines. Since they're consecutive interior angles, they're going to be supplementary. So I'm just going to abbreviate a little bit here. If it's a parallelogram, then consecutive interior angles are supplementary. In step 3, they put in the reason for us, definition of supplementary. Definition of supplementary tells us that two angles add up to 180 degrees. So that's what we're going to do. We're going to take step 2 and just make them add up to 180. So R and S are supplementary. That means the measure of angle R plus the measure of angle S is going to equal 180. And then we'll do the same thing with the second one. Angles S and T are also going to add up to 180. And that's by your definition of supplementary. Step 4, they want us to do substitution. With substitution, we're going to take one thing, put it in for another. In step 3, we have two things equal to 180. Angle R plus angle S, and angle S plus angle T. So what I'm going to do is take angle S plus angle T, put it in for the 180. And that would give me the measure of angle R plus the measure of angle S on the left. The 180 is going to get replaced by the measure of angle S plus the measure of angle T. And there's your substitution. We took out 180, we put angle S plus angle T in for it. And then if you look at step 4, you've got angle S on both sides. We can subtract angle S from both sides, leaving us angle R on the right, angle T on the left, or angle R on the left, angle T on the right. Subtraction allows us to get rid of that measure of angle S on both sides. And then the last step, angle 6, they want us to go definition of congruence. Now, if you remember the proof statement, we want to prove that angle R is congruent to angle T. Right now we have angle R equal to angle T. Definition of congruence allows us to flip back and forth between those two. So measure of angle R equals angle T, measure of angle T, I can change to angle R is congruent to angle T by the definition of congruence. All right, last one. Third proof is going to start off the same way. We've got opposite sides are parallel to each other. That makes the figure a parallelogram. This one we're going to prove that RT and SU bisect each other. RT is a diagonal, SU is a diagonal. This is our theorem that says if it's a parallelogram, the diagonals bisect each other. We're going to prove that right here. So first step again is the given. And I'm going to mark that on my picture. RS and UT are the top and the bottom. RU and ST are the left and the right. Looking at your picture there, you can see your opposite sides are parallel. That's going to make that quadrilateral a parallelogram. Step 2 they put in for us. RS is congruent to TU. Where's RS? RS is on top. TU's on the bottom. That one is the theorem that says if it's a parallelogram, your opposite sides are congruent. So we can mark those two congruent to each other. Step 3, angle, this part they put in for us, angle WRS is right here. It's going to be congruent to angle WTU, which is this angle here. If you look at those two angles, those are alternate interior angles. They're on parallel lines, which is going to make them congruent. And then the same thing's going to happen with WSR and WUT. WSR is this one. WUT is this one. They're also alternate interior angles on that same set of parallel lines. So my reason here is the alternate interior angles theorem. And now step 4 tells us we have angle side angle, which proves triangles are congruent to each other. If you go back to your picture, in this triangle up here at the top, we have angle side angle here. On the bottom triangle, we have angle side angle here. That makes the two triangles congruent. Once again, you can name the triangles several different ways. I'm going to call the top triangle WRS. That takes me from the angle not marked to the angle marked with 1 to the angle marked with 2. If I do the bottom one the same order, it would be WTU. And then once the triangles are congruent, just like we did in the previous ones, we're going to go to CPCTC, which is corresponding parts are congruent to each other. Once the triangles are congruent, your corresponding parts are congruent. Now, if you keep in mind where we're going here, we want to get the diagonals to bisect each other. So we want to get our corresponding parts to be our diagonals. So WR and WT, those would be corresponding parts. And WU and WS would be corresponding parts. So we got WR and WT congruent to each other, and the other one, WS and WU. And those are congruent by CPCTC. And then last step is the definition of a bisector. Well, we just showed that the diagonals are being split in half. They're being bisected by each other. So last step, we want to put this down here. RT and SU bisect each other. By the definition of a bisector, we showed that those diagonals are being split in half. That's how we defined a bisector. It's when a segment gets split in half or an angle gets split in half. All right, those are your 3 proofs that you will have to be able to handle on the test when we get to that in Chapter 6. Now, the next thing we're going to have you do in class is the next page in that packet of papers. Should look like this. Basically these same proofs we just did, except we're not giving you as many steps. We're not helping you out as much. There's a lot less of the fill in the blank, or a lot more for you to fill in. We didn't give you quite as many things filled in as we did on this original one. So you may want to keep this one handy, kind of look back at it as you're going through this. If you kind of get stuck, not sure which step comes next, you can kind of look at these to help you through it. And that is it for Section 2.